This is Algebra 1, Semester 1. It's the unit called Functions, number 5, and it's the lesson 1, Domain and Range, Independent versus Dependent Variable Practice. It's on CreatorMathcom under the Algebra 1 tab. You might have to Google creatormath.weebly.com to find the site. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from CreatorMathcom. So typically before I start on the problem sets, I try to show you guys how to find the notes. It can be a little difficult, especially if you don't do it very often or haven't done it yet. There we go. So here's the actual name of the website is creatormath.weebly.com. If you Google that, you ought to be able to find, I hope, this homepage. And if you're on this homepage and you have questions about the composition book, just scroll down until you see the words composition book. Follow these directions, watch these videos, adhere to these turn-in dates, and put all these things on the proper pages. And the notes, which we will go to now. On the tab of the class is 5 things, maybe more. It's the pages on which the notes go. It's the actual notes are under these tabs. And what else? The problem sets, the video like we're making now, the solution for the problem sets, and the PDF with all of the vocabulary for the entire school year is here. This, if you're not getting 100% on your vocabulary practices, you may not know that you can download this PDF to your device, and it is searchable. Just Google how do I search a PDF with whatever type of device you're using, and you will, the directions are a little bit different, just follow those directions. And you should be able to get 100% on your vocabulary practices, which is the point, by the way. All right, we're going to go to the proper semester next for the one you're in, and or the video we're making right now. So under this will be the table of contents, the all-important table of contents. It's so important that I ask you to copy this onto, in its entirety, into pages 2 through 6 of your composition book. It takes up about 3.5 pages and may take you 45 minutes to write in. But once you've got that written into your composition book on pages 2 through 6, it's got all the pages where everything goes, including all the notes for all the units and all the lessons of the entire semester. So you just do it once, and then you can go from there and you can figure out how to build your composition book in a way that I can actually check it and give you a great grade for. All right, so as we go down to the proper unit, so the unit in this case is functions right here. The lesson we're in is domain and range, independent versus dependent variable. Here's the page numbers on which the notes go. Please don't take this video's word for it, but go back and find the original table of contents at the time you're watching this. These page numbers probably will have changed. Here's the notes, the problems, the video solutions will be linked here. Fair warning, sometimes I have to click notes twice to get it to open. This one opened the first time. It should be expandable. This one talks about, given a function, how can we label the input and output, right? It talks about the function, the all-famous function model. There's a factory, and we put stuff into the factory inputs, and the factory works on the stuff and puts out outputs. Imagine it's raw material, and the factory makes it into a product. Maybe they're putting cloth, right, into the factory, and the factory makes clothing of some sort, and out comes a finished pair of pants or shirt or something like that, right? That's how a function works in math. So function, we have an input of 3 in this case. The function itself is x squared. So the function works on the input. We put the 3 in for the x. The x becomes 3 squared, and the output is now 9, because 3 times 3, or 3 squared, is 9. So that's the idea of a function in algebra. And here we have a function notation, f of x. This is pronounced f of x. It's an f parentheses x parentheses equals x squared. So f of x equals x squared. What happens is we replace anything in this parentheses with a number. So we replace the x with a 3. Now whatever's on the right side, we also replace that with the same 3. So f of 3 is equal to 3 squared. F of x is equal to x squared. That's how you speak it. And here's all that here. Put all this into your comp book. The idea of an independent versus dependent variable is the first number we put into this whole thing is independent. Why? Because we get to choose it. It doesn't depend on anything. We just select it. But once it goes into the function factory, it's now dependent upon what was done to it in there, right? If it's cloth, it's independent because we just selected out raw bolts of cloth, right? We put them into the factory and start to make it into shirts. Now it's dependent because it comes out and it depends on what the factory was making. If they're making shirts, it comes out shirts. It's now a dependent variable. So that's the idea of independent versus dependent. Input, output, function, here's vocabulary, domain, and range. Domain, all important, is the set of x values, the inputs, and range is the set of y values. Independent, dependent, input are the x values, output are the y, and other things that you need in your notes. With that in your notes, now let's turn to the problem set that we're given for this lesson. So what is the basic understanding of domain in algebra? Domain is the set of x values. The set of x values, if I could speak right. The set of x values, okay? All of the x values of a graph or set. What's the basic understanding of a range? It's all of the y values of a graph or set, right? Why are the x values independent? Because they are input first and therefore produce an output, so they are not dependent on anything else. So the x values are independent because we select them. Just choose whatever we want. They're independent. Nothing determines what we select for that. We can select what we want and put it in. So independent. Why are the y values dependent? Because once the function works on it, it's dependent on what happens in that function that makes that spits out that output. That's why it's dependent. Okay, because they are produced from the x input values or input x values that are dependent on what the x values are. All right. So what is a common model to explain a function? A factory or machine upon which the independent x input values are worked on and the dependent y output values are produced from. So that's a common understanding, that graphic we showed you in the notes just now. A factory model for, oh, we put something into the factory, raw materials, and it spit out a finished product. That's a common model for a function. What are the tools we use to illustrate the effect a function has on the input x values? More than one answer may apply. So we use certain tools. What are the tools we use? A chart or table to show input x values and output y values. A graph we use to illustrate the input x values and the output y values. And there's no way to represent, so this one's out. Okay, there is a way. We represent it with at least two, a chart and a graph, and there's more, you guys. It's just that's what we're going to focus on in this lesson, all right? So a chart and a graph. Let's look at a few of those and talk about the domain and range for each. But first, back to the factory model of a function. So given a function model below, why is the output y dependent? Why is this dependent? Because the factory must do some work on it, right? These are independent. Do some work, dependent. They're dependent on what is done to them. So because they are produced from the input x values, and therefore the y values are dependent on the x values. It just depends what you put in for x. Now what the factory does depends. So these are dependent. But this one's independent because we just select it. We pick it out. I could use a 5 or a 10 or a 15, right? Doesn't matter. I can pick it. I'm independent in my selection there, and it's an independent value. All right, given the function model below, if x equals 3, what is y? So here we have x equals 3. Here's the actual function, x squared. What's the output? So you take this 3 and you say 3 squared, put it right into the model, right into the factory, and the factory works on it. Well, 3 squared is 9. And that's all there is to it. It's a lot of big vocabulary, sort of with a simple idea of we're just putting something in, we're doing work on it, and putting something out. A result. And the result is dependent on what happens in the factory and what was selected as the input. Right? Given the following graph, what are the domain values? So here we have a typical Cartesian coordinate system. There's an x-axis and a y-axis. By the way, those axes are always the labels, right? They don't ever switch. The x is always the horizontal number line. The y is always the vertical number line. They cross at a point called the origin. Now, what is domain? It says, what are the domain values? Domain are the set of x input values. So we just look at where we start here. Here's the first point, and here's the last point. This is a -2 on the x, right? This thing that corresponds this way. And this one that corresponds up to this one is a 1, 2, 3, 4. Looks like 4. So there's something at any point here that if you go up and down this line, that correlates with a value on the x-axis between here and here. So the set that we're dealing with here, and I'd put a solid and a solid here, the set is -2, right? And I'd put a bracket because it is included. This is a solid dot here. So the bracket concludes the -2, goes all the way to the 4. And I'd put a bracket there because that's included too. So another way to write this is you could say x is greater than or equal to -2, and x is less than or equal to 4. That'd be another way. The domain is the set of x values which go from -2 to 4 in the set notation of 2 to 4. Okay, there we go. And that's it for domain. It's something about the names make it hard for students to remember, but that's what domain is. Given the following graph, what are the range? Well, we just did the x. Now let's examine the y. Our values go from -1, 2, 3, 4, 5, 6. So -6 here up to 1, 2, 3, 4, 5, 6 here. From -6 to +6. So this one here. This is called range because now we're talking about all these values here on the y. So everywhere that you correlate this way to that graph, there's some y value that explains where this is, right? So all of these are included from -6 to +6. So the range is the set of y values which go from -6 to +6 in the set notation of bracket -6 because it's included to bracket 6 because it's included too. Bracket means it's included. If we did it in inequality notation, this would be a y. The y would go between -6 and +6, and it's got an equals, which means it includes those values. That's what this whole set notation means here with a bracket, -6 comma +6 bracket. Bracket means those values are included. And again, this is building on other lessons. We've talked about set notation before, and we will definitely talk about it again. So it should not be completely brand new to students. Given the following graph, what's the domain? Domain, so here are the x's from here to here. So from -1 to 1, 2, 3, -1 to 3, and it includes the values. So the domain is the set of x values which go from -1 to 3 in the set notation here. And if we were to put it in this way, we would say x is between -1 and 3. Just like that, inequality notation. All right, given the following graph, what are the range? So now we're just going on the y. Here's here, and here. This is 1, 2, 3, 4, 5, 6. So -6 to 1, 2, 3, 4, 5, 6. So it's a different problem, but it comes out the same range. Range is the set of y values, which go from -6 to +6 in the set notation. And you'd have a y in there, and we could go like this from -6 to +6, if I can write. All right. So here's another way we may be represented, have values represented to us of x and y. What's the domain? Domain is the set of x, so it looks like the set of x are all these 5 to 8, right? Now the thing about this is we don't see a line going between them. So it's a little bit hard to make an assumption. At the very least, we know the x includes 5, 6, 7, and 8. And if you looked at the last lesson we did, there was a thing on discrete values versus continuous, right? This would be a set of discrete values at the very least. And if we had a graph, we might be able to say they were continuous, but we don't at the moment. So the domain is the set of x values, which are 5, 6, 7, and 8. 5, 6, 7, and 8. All right, given the same chart, now what are the range? The range would be 15, 18, 21, and 24. 15, 18, 21, and 24. The range is the set of y values, which are 15, 18, 21, and 24. X domain are x values, and range are y values. And that's it. Usually when students remember it, they're like, oh yeah, this was really simple. But until they remember it, they're like, what was that again? The domain is the set of x values, which are from. Okay, here we go, domain again. -2, -1, 0, and 1. So this one, from our answer choices, I'm going to go with this one. It looks like they're now saying that these are not discrete points, but this is a set of all points included in between them. -2 is being included with a bracket, 1 is being included with a bracket, and every number in between there is being included. So the domain is the set of x values, which are from -2 to 1 in set notation, bracket, -2, comma 1, bracket. Now they're going to ask about domain, and I assume they're going to go ahead and use a set notation on this. Range, that is. Range is 2, 3, 4, 5, but they're going to just say from 2 to 5, including 2 and 5. Right? And so the range is the set of y values which go from 2 to 5 in set notation, bracket 2, comma 5, bracket. So make sure that you're matching up the title of this video with the problem set you're doing, otherwise it's not going to make much sense. This is Algebra 1, Semester 1. It's the 5th unit called Functions. It's the first lesson within that called Domain and Range, Independent versus Dependent Variable Practice. And you'll find it on CreatorMathcom under the Algebra 1 tab. Hope this helps.